Good morning to all. In this video lecture, now we are going to discuss the design of Murray machine. How to design the Murray machine for the given problem statement. So we know that there are two find automata with output machines are there. One is Miller machine, second is Moore machine or Murray machine. Here in case of Murray machine, output is associated with the state itself, or output is dependent on current state only. In case of Miller machine, output associated with the transition. In case of Murray machine, output is associated with the state, or output is dependent on the current state. Means current state itself decide the what will be the output for the given state. Now we can define the Murray machine by using 6 tuple. Here you can see that 6 tuples are capital Q, summation, triangle, delta, lambda and Q0, where capital Q is finite non-empty set of state or the number of states which are required to design the Murray machine for the given problem statement. Summation is the set of input symbol, triangle is the set of output symbol or output alphabet, Q0 is the initial or start state of the Murray machine. Delta is a transition function, mapping function or next state function. Means here current state into current input alphabet, that will give the next state. And as I said that in case of Murray machine, output is dependent on current state only. That's why lambda is the output function and current state itself will give the output alphabet triangle. Now we'll design the Murray machine. So here one problem statement is there: design a Murray machine for one's complement of a given binary number. Okay, now here we want to design one Murray machine for the one's complement of a given binary number. So we know that what do you mean by one's complement of a given binary number? Simply we have to invert the given bit. Let us consider one example. If the number is 1 0 0 1 1 and 0, if this is the number, then what will be its one's complement? So 0 will become 1, 1 will become 0, 1 will become 0, 0 will become 1, 0 will become 1 and 1 will become 0. This is nothing but the one's complement of a given binary number. Then how to design the Murray machine for the given problem statement? See here, there are two outputs are possible. Either after taking the one's complement of a given binary number, either we are getting the answer as a 0 or we are getting answer as a 1. Means if input is 0, it will generate the output as a 1. If input is 1, at that time it will generate the output as a 0. So we are going to design the Murray machine for the same. So here this Q0 is the current state, okay, or initial state, which will generate the output as let us consider Q0 is the initial as well as current state. So I will draw it. Okay, so Q0 is the current state, which will, as it is the initial state, so it is shown by using arrow, and which will generate the output as, which will generate the, let us consider which is nothing but 0 output state. Okay, and now we are in Q1 state. Q1 is another state. Q1 is another state which represent one output state. So if Q0 having 0 input, at that time in one's complement 0 input is there, then it will going to generate the output as a 1. So Q0, if 0 input is there, then it will be in the Q1 state. Why? Because output is 1. So Q0, 0 input is there, it will be in Q1. If 1 input is there, so if given binary number is 1, so its one's complement is what? 0. So 1 output state is 0 output state is what? Q0 itself. So for input 1, it will stay in same state, because for 1 output will become 0. Same way for Q1, if input is 0, so output will be 1. That's why it will stay in same state for 0 input, because 0 input output is 1. For 1 input output will be 0, and for 0 output state is what? Q0. So that's why it will be in the Q0 state for the 0 input. This is nothing but the Murray machine for one's complement of a given binary number. Now we want to design the transition table. For the given Murray machine. Okay, so here capital Q is there. Okay, and this one is the lambda output function. This in this column we need to mention all the state, and here it will be the delta. There are two inputs are there, one is 0 and another one is the 1. So delta means next state, lambda means output function. Okay, so as there are two states are there, one is q0, so q0 is the initial state, so it will be shown by using the arrow in case of the transition table. So q0 and another state is q1. In case of Mealy and Murray machine, we don't have the final state, so we need to show the final state. Okay, now q0 after accepting 0, so one more thing, in case of lambda, this we need to write down directly output. So q0, with q0 which output is there, 0 is there, so I'll directly write down 0. And with q1 which output is there, 1 is there, so I'll write here 1. So q0 after accepting 0 as input, it will generate the q0 after accepting 0, where it will be in a q1 state, so I need to write down here q1. q0 after accepting 1, it will stay in the same state, so here I will write it as a q0. q1 after accepting 0, it will stay in same state, means output will be q1, and q1 after accepting 0, it will be in the q0 state. So this is nothing but the transition table for the Murray machine which we have designed. Okay, now we have to design one more Murray machine which will increment the given binary number by 1, and okay, so try to design one machine which will increment the given binary number by 1, as well as one more Murray machine which will calculate the 2